Hi, my name is Daniel Johansson, student number 300258516 for SED102 Engineering Design CAD. This is my presentation for the Team Design Task 2. This will be the presentation of the final design concept for the Bendy Downs property. I've chosen to provide a low-cost alternative to current insulation techniques to combat the extremes of weather and temperature experienced at the Bendy Downs property. Next slide. The first slide details the design targets that I set out for the original design specification. These are basically the main factors that I considered important to the project when considering the solution. The insulation, of course, had to be a low cost, hence the first one. Temperatures at the Bendy Downs property range from a mean of approximately 4 degrees as a low in winter to mean highs of about 36 and above during summer periods. But the temperature has been known to spike dramatically. They've experienced temperatures up to about 47 degrees in summer, and it's not unusual for temperatures to reach 40 degrees on an average day in summer. Due to the isolated situation of Bendy Downs, the design obviously had to be quite simple, both in operation and maintenance. Breakdowns should be easily fixable with only basic tools and plumbing supplies, and of course the material should be readily available should the need arise. No waiting for overseas parts to be imported or anything like that. And of course it needs to be easily expandable. The Bendy Downs property, the Cooma Traditional Owners Group has expressed an interest in developing the property further past Engineers Without Borders, and so obviously an expansion further down the track is going to be desirable. The design also had to be efficient, which is my next design target, so as to keep cost and simplicity as adequate levels. This is obviously a core idea of the entire design target process. It should also give some employment to the local labour, and so it needs to provide that sort of community spirit. And obviously all the materials should be sourced locally, and so as they can be easily sourced again later on down the track once the expansion or maintenance or repair is necessary. The design, I decided at the design specification review, needed to be time efficient. The redevelopment shouldn't lose a lot of time just to put in some insulation. They should be concentrating more on the actual building itself. And obviously the redevelopment shouldn't lose momentum through having projects like this overcomplicated. This will also cut down the amount of time required to expand the system later by making sure an efficient process is followed in the first place. Next slide. These are the 4 competing designs that I considered after organising a few friends and relatives over dinner as a bit of a focus group. We considered a larger range of alternatives, but these are the 4 that were the real contenders. They ranged from things that I wouldn't normally consider insulation to some really great ideas that just weren't applicable to this sort of property. They lacked the simplicity, they lacked the sort of ease of maintenance. As I said, these are the 4 that really stood out. Air conditioning, I'm talking air conditioning as in the normal stuff you'd see in your house or your office space, whether that's reverse cycle or conventional evaporative air conditioning. Passive insulation, so insulation that doesn't actively do anything, no moving parts. Basically that's the mineral wools or the foil, those sort of insulation techniques. The heat pump was the next one, which is similar to the air conditioning system. It works on circulating hot water around it circulates hot water around the property through wall ducts and is used mostly as an air cooling device rather than actual insulation. I considered these sort of non-insulation techniques more for utilising them to cool within the wall cavities rather than just sort of the conventional use of a duct in a wall or a roof. And then of course there's the ground coupled heat exchanger, the GCHE, as I will refer to it to save this presentation going into the hours, which is a system currently employed by German passive house designing, which is obviously focused on low impact, environmentally friendly and sustainable housing development. Next slide. The method of selection. With the focus group, I asked the participants, 8 in total, to form opinions about the design metrics that I've chosen here, subcategorised into economic, so your cost. These are sort of to align with my design targets. Economic, so my cost, simplicity, efficiency, and time. I sort of put in with efficiency. I didn't think it was as much of a consideration this time around. Once I'd sort of figured out where the designs were going, time efficiency seemed to fit better into the efficiency category. On this table, I asked everyone to score a 1 to 5, 5 being the highest, on what they thought each system would perform. I then averaged the scores, set them out into a table. There's running totals throughout to sort of get an idea of what met which design target and where, and sort of how well it met that design target, to make sure that what I chose at the end not only represented an overall score, but I also performed well in each of my design target categories. As seen, the heat pump was not popular, with most ratings being the lowest among the 4 ideas. Air conditioning and passive insulation both showed very polar results. Obviously with air conditioning's running costs, it scored a 1 because it's very expensive to run, whereas passive insulation, it doesn't have running costs, so it obviously scored a 5. As I said, very polar results, but yeah, mostly being the best or worst in each case. Next slide.